Sorry.
No worries. Thank you. So that quickly kind of transitioned into getting on the product management side, looking at the landscape of AppSec, more specifically around our competition at Checkmarx. And now I lead our global enablement team and work with the field on educating them around a lot of the great research that Checkmarx does, as well as what we're seeing in the industry. Love food. The only thing I think I love more than technology is food. So those are my two passions in life. So the three areas we'll talk about today primarily, again, everybody's probably familiar with at some level the supply chain and more specifically around software. We'll talk about AI package hallucinations, which will just give a quick overview of what that is and what threats that may provide, as well as threat prevention towards the end. So for those, just a quick level set to set the table here. For a traditional supply chain, typically there's some widget or some product that is being constructed. It is built at a factory. It is shipped on trucks to a certain shop or brick and mortar store, and then consumed by customers. Software supply chain, the analogy still holds. You have developers building local code, pulling in source dependencies. There's typically a package manager, or I'm sorry, a build system like Jenkins that will build and package the application. That is sent then through a network where an application repository, think Google Play Store, will then have and host your applications. And then lastly, where you have users either consuming or reaching into those deployed systems. So we're going to be talking about a lot around the building and the delivery of software, and then how threats may come into play. All right, so software supply chain attacks. This is where some of the concern comes in. This is some data from Forrester as well as our own research team. So it's sixfold more people are concerned about malicious third-party components this year versus last year. So we surveyed all of the CISOs within the industry, within our network, and 90% of those CISOs are concerned about threat actors targeting these open source repositories and malicious packages. And then Sandy from Forrester also saying and highlighting the focus, how this is a huge threat surface and something that needs to be addressed very quickly. So a quick question for you all. So has anybody used open source packages? Hope it's everybody, but my buddy Luke. Luke, you've used it. Perfect. Anybody have any guidance on how you would know the correct or if it's safe to use that open source package? What does that process look like? Is the repository maintained? Does it have good health? Is it actively being contributed to? Are they fixing bugs? Are they releasing regularly? Great. What else? Is it signed? Say more about that. What does that mean?
Of the open source as well.
Excellent. Okay. What else?
Audit source code yourself, or look at software and stuff that source code that it sees that code is safe.
Yes. Yeah, absolutely. So audit yourself, self-review. Perfect. All right. So maybe say what kind of security tools, what kind of security scanners would find those types of information? So an SEA scanner, so looking for CVEs associated with a package. Perfect.
Yeah, I was just going to say dependency management tools.
Dependency management.
Identify known.
Perfect. So I love all of those. These are four kind of areas where I think some people might have the illusion or the false sense of security that it is safe to use all open source packages. So yes, it's open for everyone to look, just like as you advised, you can just review it yourself. If there's an issue, if you find it, somebody's probably going to point it out and they're going to notice and they'll address it themselves. So kind of relying on others. There's other scoring mechanisms. So you'll see package managers with star rating systems or number of contributors and other good metadata to see the health of the package. And then it's open to the public. So you just have this sense of trust. So we're going to get into some stories of real world examples, relatively recent. And we're going to get into what the difference is between malicious versus vulnerable packages. So who wants to take a crack at what's the difference between a vulnerable and malicious package?
Malicious is intentionally putting backdoors or things into it to try to
Yes.
weaken it. Versus
The intent is malicious by design, whereas a vulnerability is a mistake, an accident, an oversight. Perfect. What else? You hit on number one, intention. This feeds into that a little bit, but does it contain vulnerabilities? Again, there's scanners that may find CVEs associated with that package. What you'll see here quickly is those are actually not, there's no CVE associated with malicious packages. There's no CVE assigned to that package. And then tied to that intention and what you were alluding to, the risk behind it. So a package may be vulnerable that may or may not be exploitable, depending on circumstances, a chain of different vulnerabilities. It may not come to fruition. Malicious packages, by design, can be executed and the risk should be substantially higher. So when you're a developer in the mindset of a developer, if they are asking for a package, it seems very straightforward. I want this package to do X. This package claims to do so. I will bring in that package. In this case, this is CNC JavaScript. This developer pulls in this package. Behind the scenes, and really without dependency checkers or validation, they would be blind to the fact that that calls another package, which calls other packages, which calls other packages, and more packages. To the extent this may go 70, 80 levels deep in dependency trees for open source software. So are you going to be able to review maybe the first package and the source code associated with it? Is it feasible to go check all the other packages that it calls, all their dependencies, and so forth? So you can see how quickly the problem in the manual review will not scale. So in this case, that developer brought in one package, and again, just one JavaScript library added actually 811 additional packages from 611 different contributors. Just to help with kind of putting this in perspective of why this problem is getting out of hand, if it's not clear already, the number of packages per month across the popular package managers, and this data, I apologize, is about a year old, so it's much higher today. So over 115,000 for Python, 152,000 packages released per month in NuGet. NPM for all the JavaScript packages at 1.6 million, and then 170 for Java, 170,000 for Java, and 32,000 for PHP. That's per month. So it's very difficult to keep up with the sheer velocity and volume of the different packages. So we're going to have some fun. We're going to dig into how malicious actors are actually taking advantage with you asleep at the wheel, not paying attention to all the nuances and the tactics and tricks they use to actually create malicious packages, as well as disguise them so that more people will use them and get past dependency checkers, get past security scanners, and get past manual review. So since this one is a hot topic everywhere, we're going to talk about AI package hallucinations first. And simply put, when you ask AI a question and it does not know the answer, it doesn't just say, I don't know. It'll actually just make up things to appear like it's reality, which is fun for some scenarios, which is dangerous for the scenario we'll be talking about. But we asked ChatGPT, who was the sole survivor of the Titanic? We got a lovely story about Charles, and he was a British baker, all these great things in his history. Problem here is Charles isn't real, and there were way more than just one survivor with the Titanic. So this is just to highlight, you can't trust everything that AI produces. I think we're all well aware of that, but we'll talk about how that fits into application security here real quickly. Quick bonus question, the debate on whether Jack could have survived on the Titanic. Anybody think that he could have survived with Rose? Okay. Someone actually put a nice little drawing and it's very clear they can play cards, they can lay down next to each other. So Rose kind of left our buddy Jack out there for no reason. All right, back to AI package hallucinations. So this approach is an attacker asks for ChatGPT in this case. They're looking for some capability where an open source package exists, and I would like to use that. When AI says use this package, they go look for it. It's not real. They look in NPM. They look in any of the package manager repositories. It doesn't exist. That gives the attacker a great idea. I will go create that package. So for anybody else asking that same question, it will exist, and it'll take them to my package that I created. And that's exactly what happens here. The attacker created the Python package. Now you have our innocent user asking the same question. Of course, ChatGPT responds with that package. It is now real. This user is not doing any validation of the safety of that package, pulls it in, and they are immediately impacted and infected with that malicious payload. And just to show you at scale of the impact, this isn't one or two things. So Vulkan.io asked for packages for both Python and Node. And 1/4 of the packages, or 1/4 of the questions came back with unpublished packages, and just under 2 to 1 for the Python packages. So this isn't one-off, and this isn't just, you have to get lucky for this to happen. It's way more common than you would expect. So next up is dependency confusion. This has been an attack approach for multiple years. We have some great research at Checkmarx that has identified not only the packages, but the actors, and kind of their processes that they operate in to prevent these from spreading. So we're going to talk about what that looks like. So you may be familiar, every open source package has a version associated with it. So in this case, we have at the very top public repositories. These are your open source packages maintained across the open source community. You also have in-house your own private repositories. You have your build server that based on the package, the version, and the instructions, it'll actually build out that application with those dependencies. And that is by design how this has worked for a very long time and should continue to work. The problem comes in when you have something called dependency confusion and you introduce a package with the same exact name with a different version number. So if anybody want to speak to when installing a package, how that process works? Anybody familiar with? Please.
I mean, in which context? Like normally just pulling down a package?
So as a developer in my manifest, I want to pull in this case, company infra is the name of my library. So what does that process look like?
Okay, so if you're doing it internally, it's probably going to look at your internal repository system. If you have a private one, see if there's a match on the package there for the version requested, the package name, whatever. And if it isn't found, then it may go out to external publicly facing ones. And yeah, most package systems, you're usually going to have a version assigned, but often developers will just say a minimum version and it might go to newer things. And then it'll pull that in, and then it'll pull in all the dependencies that might have depending on the language. So it can go pretty deep.
Yeah, well said and spot on. And what happens if you choose latest as your version instead of an?
If you do latest, you're just going to get whatever is tagged as the latest version. Depending on the language, it'll either actually have a tag called latest, or it'll just do the biggest number of a major, minor, patch. Perfect. Like Semver.
And to that point, it's in very small text. Apologies for that. But company infra here, if someone has a public, so one of the package managers, someone deploys this package with the same name, and in this case, the version number is 999.999.999. So that would absolutely be the latest, and that would supersede the intended package of company infra version 2.2.3. So there's an order of operations in what you're instructing when building the application of which package is actually the correct one. Now, you know this, some of you might know this. I promise you most developers probably aren't too familiar or comfortable with the order of operations that take place. So some of this requires education on the process. Some of this requires checks in place so you prevent this from happening, which again, they can be easily prevented, but there needs to be clear understanding on this process. So in this case, company infra was injected into the build server with the wrong version, and now you have a malicious package sitting within your application, and without much inspection, you may not be the wiser to that taking place. And this is exactly what happened with PyTorch. They have a nightly build that relied on the package, the build package Torch Triton. So they had it packaged and included in the PyTorch build. Unfortunately, outside of this process, someone added the dependency of Torch Triton to a malicious package equivalent of that. So same cloned that exact package, injected their malicious payload, and then allowed this build package manager to pull that in prior to Torch Triton actually building the application with what dependency intended. So first priority of the package, to your point, gets executed first. And then in this case, PyTorch nightly build, it was already installed, so it did not bring in PyTorch's intended third-party package. All right, next up is pretty straightforward, I think, in terms of what most are familiar with in their day-to-day. Has anybody made a typo before while writing a Word document or an email? Same thing applies. Don't somebody say no? Nice. So same thing applies here. You have very popular packages. You swap two letters, your common misspellings. Case of the package comes into play for some of these package managers. So depending on how you write that package, either in your manifest or as you're developing your software, you may encounter pulling in the wrong package. So here's a great example. Again, these are all real-world examples with huge impact to any of those affected by this, but the legitimate package for this memory storage driver, you can see by the name of the package, they're actually identical in spelling and with a hyphen shortly after local forage. And the only difference here is it's camel case and NPM. So appear to be identical, appear to be the correct package. You copy and paste this from NPM or you pull it in through your IDE. It appears correct. It functions correctly. You'll see, and we'll talk about how this metadata can be spoofed. It appears that the number of, in this case, I'm sorry, the weekly downloads is 12,000, and this one there's only been 3. So this one, to your point about inspecting the health of a package, is a little suspicious. But if you pulled it in by mistyping the characters and capitalizing the S and the D, or not capitalizing the S and the D in this case, then you would be pulling in the incorrect package. So this happened with Discord or Discrod. So just swapping 2 letters in a very short word, and this opened up to a massive attack from a network of hackers. So the first step here, you install Discrod from the developer's standpoint. We're just going to talk about how this spreads across the ecosystem of that developer. So first, they pull in the wrong package. Now, in this case, we had the login tokens being read by this new malicious application. The go through to Discord actually still is successful, but behind the scenes, they're capturing all of the sensitive information, reading those credentials, and once they have this attack set up, of course, they want to spread it to others, and so they actually use this information to spread to all the victims' friends across their Discord server. So this one spread rapidly and impacted a very large subset of Discord users, all because of a very simple typo squatting mistake.
Wouldn't code signing make that a non-event?
And that's what happened, I believe, after this. But yes, absolutely, code signing would actually validate that you were using the right package. That's why it was a great point earlier. Yeah, go ahead.
I was curious too. Yeah, it seems like a pretty basic integrity control that you shouldn't have 2 packages named the exact same thing. So is there a reason that they don't just dedupe those on their side? I mean, I know it's free, but it seems odd to just say, yeah, we have 2 with the same name. They're totally different, and that's fine.
So it's a great question, not only on this matter, on just who's responsible for the integrity of the packages. So if you talk to NPM, if you talk to GitHub, We'll talk about another attack where there should be controls in place. And actually, our research teams reached out to both of these companies, and their view is it's not their responsibility. Now that's shiftly changed. It's changing over time, and I think there's more precaution they're taking. But to their point, it's their create ecosystem that allows an open source community to deliver or create code and name it whatever they would like. So who are they to come in and say that you can't name it disk route? So it's a gray area, and really the accountability is what it's a collaborative effort that needs to happen. But to your point, the ownership of who's responsible for that is why attackers can take advantage of this. There's a great point. You would think that there should be some sanity checks in place and someone overseeing some of this. All right, last up on the 4 common ones is repo-jacking, and then we'll go through some real-world examples. This is another one that, to your question, GitHub struggled with, and actually they've fixed some of this, but not all of this. But an attacker can either compromise the account, you can sell credentials on the dark web and get hijacked, and we'll go through one of those stories. But there's also logic flaws within the naming and the accounts within GitHub that open them up for attacks as well. So we'll talk about repo-jacking, which at a high level is hijacking the account or the repository owner for a certain package.
So would you consider what was the XZ or RZ or what are the one that recent?
Details.
Would that be repo hijacking? Because they did the valid account and then they kind of hijacked the build process and things like this to inject their stuff, or how would that be considered?
Yeah, was anybody else familiar with that one that wants to speak to it?
Or that case, they had compromised developers, and they inserted code into the development process and used that to promote their hack. Interestingly enough, scanners wouldn't have helped you in that case. So if you had a private repo, you wouldn't have been able to figure it out. It was just somebody noticing the impact on the performance
Yes.
that cued them to noticing it.
And I believe that was embedded for a long period of time, correct? That was ongoing for a year plus?
I think it was less than a year, and then
Okay. So it's
but
not,
yeah,
okay.
it was only noticed because of that performance impact. Somebody just happened to be investigating that.
Yeah. So here is some of that, the logic in how you can hijack a GitHub account. So in gitbucket.com, I have my org and my repository. That is just the naming convention within your organization, which is your name and then the repository under that. Problem is, if you change the repository name, it's going to get a new, or by the way, if you change the repository name or the organization, it will get reassigned to that new URL structure. Now, the old structure still persists. It just does a redirect to the new repository because this is now empty and does not exist. The problem is, what if someone comes behind you and takes over that account, which is available, and changes their name back to my org and my repository? So now there is no redirect, and it goes directly to the victim or the attacker's repository that they would like to use. So this is a design flaw within GitHub. We did make them aware of it, and I think they are working to fix this. But this is one area where we've seen attackers take over packages that have been renamed and use that strategy for their exploits. So this one's about a year and a half, maybe, no, it's probably longer, probably 2 years old at this point, but there's a gentleman by the name of Brandon Miller. He's been contributing to a lot of, to RIA and a lot of other packages as a very credible and honest developer. Event, PubSub, Node CMD, RIA are all very popular packages and widely used. Node IPC, you can see, has over 1.1 million downloads. Again, reputable developer, reputable package. When Russia invaded Ukraine, he decided to take it upon himself to create something called protestware and actually inject code into this well-known package. And again, up until this point, well-respected and deemed safe to use. He added a very kind of confusing code to the package as he introduced a new feature to support that new version number. It kind of looks a little off here, but if you actually break this into something more readable, you can see something very clearly here in the logic where he has an if statement where if the user's country name, meaning they reside in Russia or Belarus, then they will delete the password file, the parent directory, the grandparent directory, and root. They will also overwrite other files, which we'll show you in a second as a result as well. So this is just kind of hit on how they identify the IP. They called the service IP geolocation. They would look up the country name, and again, if that existed if the location of the developer or the one pulling in this code lived in Russia, then he would actually overwrite any and all files within that directory, wiping them out and replacing them with a heart. So his stance was an interesting one. Download my software for free, so I'm allowed to wipe your computer. And this is, he didn't see himself in the wrong here. And he then called it protestware. So whether you agree with or disagree with any of the politics behind Brandon, the question comes into play as far as, with someone in that role, with that ability, do you trust that they would do this? And the other packages you saw them working on. So this was a very interesting and confrontational event, but this was his view. So I saw a question back here.
Yeah, on the GitHub issue where you generate fake accounts, you can set up a corporate account where you're using SSO to sign on and to for affirm credentials.
Correct. Yes.
So that's a method of protecting yourself from that.
But does that protect you from the open source libraries managed outside of your organization?
No, it's just your organization.
Gotcha. So anybody have thoughts on Brandon's approach? Was he in the wrong? Was he in the right? What do you feel? Not the politics.
I guess what I'll say is I'm surprised that many open source repos. So my company has an open source project. Even me as a founder, I can't push code without it being reviewed by another human. So it kind of blows my mind that there are maintainers that they themselves can put whatever they want in their repo with no other eyes on it. But yeah, I mean, it's whether you agree one way or the other, it's
Right.
super disrespectful to open source and it's super harmful to the ecosystem where people can't trust it anymore.
Absolutely.
Or it erodes trust, which I think is harmful.
Yeah.
But
Especially malicious activity. I mean, sure, disabling himself would be one thing, but actually deleting the system is a whole nother story.
Yeah, one other thing is that, if he destroyed trust in something where we really shouldn't have trust, maybe that was a community service.
I think
Same.
what really complicates this is he was a very reputable, trusted, and credible developer who overnight, so to speak, decided to do this. And so what do you do in cases like this? A previously credible developer organization that now decides their values don't align with yours or whatever, whatever it is in this case. So that it super complicates this.
Yeah. Yeah, it's definitely a problem. And I think to the question, I think earlier, yeah, he was a great developer. He was contributing this package for 7, 8 years. And he obfuscated the code enough that if you were just quickly going over the code review and you saw obfuscated code, you probably don't think twice. And then maybe that's just something you don't necessarily need to review. And so in the code diff, this kind of was passed over. And as a maintainer and owner of, or a main contributor of the package, he had no problem forcing this through and impacting, I think, 2 different versions on this one specifically. So another way to spoof or kind of convince you of the reputation of a package is another concept called starjacking. So if I launched a malicious package, even if it was Discrod, you saw that one that only had 3 downloads, that's a little suspicious. If I can make it look like there were 1 million downloads, it was starred by 2,000 people, and there were 12 contributors, all with great GitHub contribution activity, that hides my intent or may have you have some false sense of security and using that package. So this is still very easy to spoof. The video I'll show you here in a second is, our research team creating this in production, but disclosing it to GitHub as a flaw, and they're either slow or resistant to actually change some of these things. So in this case, we have PAMPI.io or PAMPI, identical code, identical documentation, completely cloned repository. The only difference is the IO in the first one, which is correct. And the second one without it, same version numbers. So very close to the same package. So the only thing unique about the IO version is it includes an extra dependency that does not exist in the original one called redapty. So, did I have it backwards? Left side should be correct. IO is the original one. PAMPI without it is the cloned one. Yes, thank you. So the difference here was one of the URLs was swapped out with a White Evil 1990 Heroku app code bin. And what happened after this was, again, the appearance, so it's completely cloned, and I'll show you again how that process works at a high level. But exact number of stars, number of forks, and open issues. So they cloned it completely, including the metadata. So in this case, we're going to walk through how easy it is to actually create a package. In this case, we're going to make up our own fake name, and we'll delete it immediately afterwards. But this was a supply chain demo, version 1.2.3. And we're going to go find one that's popular, one with a lot of stars, one with a lot of contributors, one with great metadata to clone and steal, essentially. So in this case, we just stole 9,223 stars from the Economist eBooks GitHub repository. We are going to put in some malicious code. And this package, supply chain demo 1.2.3, you can see immediately it's about 1 minute old. Already has 9,000 stars, 1,100 forks. And if it had open issues from the original repository, it would show up there as well. So it's that simple to clone the metadata. It's also very simple to clone developer activity. So if I'm brand new or want to hide my identity, I create a new user profile on GitHub, but I want the history to show that I've been a developer for a long time and I am contributing code regularly to open source projects. So in this case, Zach, you saw it real quickly, but before all of the green, which this is ridiculous, by the way, nobody would have this many contributors. But to make the point, it's very easy to spoof his activity. It's very easy to say he works for Google. There's no validation done here as well. So Zach, if we're going back for some of the quick sanity checks, this guy checks out. Now, this is a little outrageous for the level of activity, but if you did it closer to reality and you saw that he works at Google, he's contributing to applications, someone's coming to help my open source project, I would let this guy come in as a contributor and seems like a reputable guy to trust. So these are two very easy to do hacks that will spoof or create misleading information, just straight up misinformation, and give the appearance of being reputable, which is a challenge. So as you can imagine, these things are very hard to track manually. We talked about some tooling that can help. We talked about some processes you can put in place. And then going back to the sheer volume, we just did 1 or 2 examples of real world examples of exploits. But in reality, the scale of this and what your organizations are typically using, I imagine, are in the thousands to tens of thousands as far as the open source libraries and dependencies that they bring in. So we can pause here. I just want to have a quick kind of open discussion on some other things. I listed some of the ahead of time analysis because we talked about once the malicious packages is brought into a developer's workstation, you don't need to wait for that exploit to take place later on in the build process. It can actually infect and make an impact to your company the moment it hits the developer's workstation. So ahead of time analysis is critical here. This is different than a CVE where, again, stars align and you need to build out an exploit associated with multiple known vulnerabilities in open source packages. This is a whole different concept and has a much higher critical impact to organizations. So there's ahead of time analysis that is suggested, and we'll talk about some preventative measures on the next slide. But is anybody willing to share kind of what they're doing today or what solutions they have to prevent things like this?
Yeah, one of the things you can do is have an internal repo that you vet software coming in before it's posted, and then you do your own signing and make those packages available internally for development use, not letting them go out to draw that from the internet.
Perfect. So in that case, you have a monitored and reviewed list or a whitelist allow list of all the different packages that your company allows. And if any developer is trying to use anything outside of that list, they need to go through a process that validates, gets it approved for use within the company. Yeah, very nice. Anybody else have any input?
Anyone online got some ideas?
Anybody online? Our Zoom friends, do we have any questions? I see 4 in the chat. I see some Gmail accounts getting passed around.
Yeah, always the question with the online having your own personal repo inside from the company wise. It's still very heavy activity for someone just to be doing that analysis wise. Person or people as the case may be, because you're showing that other one, it's at 811 packages. Is your internal repo going to have all 811 packages? It's going to have to.
Yeah. And how frequently are you checking the versions within those dependencies, right? So it's not just I've checked it once, I deemed it safe, I trust this version. Behind the scenes, their dependencies that package is using can be very quickly impacted by any of the other changes to those dependencies.
Yeah, I mean, I think part of the problem too, is Vern sort of alluded to it, that's a great solution. That's expensive and difficult and time consuming, right? So, when you look at like social engineering or fraud, it's how big is the incentive? And for a developer who's trying to get some code shipped, it's super gigantic, right? So for them to be like, well, I don't have this package, it's not my internal repo. Oh, I guess I'll just go home till tomorrow and it gets approved. Yeah. That's tough. I'm just saying that's a difficult position for those people to be in too. There's not an easy answer, I don't think, just given those huge forces moving against each other, Yeah.
Any other questions or feedback on just the topic in general before getting to preventative measures?
Use case you showed earlier with the metadata.
In the use case you showed earlier with the metadata, what's going on over there? With PyPy, I can just self-report stars. I can just set that to whatever I want when I upload my package.
So I don't know the exact tactic they used, but it's lack of controls. And I think there's probably APIs and things exposed that allow you to manipulate data.
Got it.
So they didn't show me
okay.
They gave me the black box and access to the.
So it's not necessarily self-reporting, but rather some other backdoor or something where they.
Correct.
Figured out. Okay.
Correct.
Got it.
It was repo squatting. So maybe were they taking on an old repo that already had the stars attached to it? Or was it the same? Or is it just?
No, this was manipulating data.
Okay.
After creating, because that package was brand new that it created in PyPy, and it already shortly after being created updated with a metadata around contributors, pull requests, stars, and other data.
So this is maybe a hard sell for some folks or organization, but like for me with teams that I've managed in just engineering in general, we always a strong questioning of why you're bringing in a package when you're bringing it in to try to reduce the amount of packages. So as a joke, I would say avoid JavaScript and Python, but because those ecosystems are all about, one-liner packages that you pull in. But I'm biased. We're a Rust shop, so. I noticed cargo's not up there,
It's
so.
not on there, no.
But yeah, I mean, I don't think there is a good solution. There's, yeah, it's a, it's kind of like what Matt said about it's a matter of risk versus reward and how, how focused or worried about this problem you are. LLMs are probably going to be really helpful in the currently or in the not too distant future with tooling for for example, like the obfuscated code. Well, one, as a code reviewer, I would never let that go through if I can't read it, right? Like that's bad code, but as a maintainer, he probably just forced it in anyway. But an LLM can look at that and tell you exactly, describe this is what the code's doing. And you'd go, oh, it can delete code, right? Like that's absolutely, or delete your file system? Like absolutely not. So I feel like there's probably tools that are out there or soon to be coming that'll probably help with this problem.
So behavioral analysis.
Yeah.
So the other talk we do is poisoning LLMs. So we'll talk about that later.
Sure.
But this same team's, yeah, so it gets, anyways, go ahead.
So has anyone ever done like an analysis of those 800 packages? How many of them are actually used? Because like when I write like web apps, I just have like a requirements.txt that I update. And then if sometimes when I look back at it a couple months later, it's like, oh, I abandoned a third of these packages already. I'm just curious if anyone ever has seen any data of like that. Just stay
personally have,
unused packages. Yeah.
Yeah, deprecated. Yeah.
Well, so like if it's listed in the whatever your requirements.txt is, I mean, do tools like actually go out and say, hey, did you actually import this package anywhere? Or did you add this at some point thinking you were going to use it and then you abandoned it and just forgot to take it out of the package? Right.
Goes back to the use a real language. No, I'm just kidding. I'm just biased, but yeah, I mean, static analysis tools can usually catch like dead dependencies, and you can prune out code that isn't necessary, but that doesn't prevent you from like pulling in a malicious package, right?
Yeah, and there's levels. It goes back to the health of a package and whether it's been transferred ownership, whether there's active contributor activity to it. So yes, I think there are tools that will check the health of packages, but to your point, the dependencies of the dependencies of the dependencies, to understand that is a bigger problem to solve. The other point, at Checkmarx and other companies do have the ability to connect the two. So not only are you pulling in the package, but are you importing it and actually referencing the malicious code or the CVE associated with it in a manner that makes you exploitable. So it's called like reachable path, or reachability is typically the term used for that, but that helps you prioritize. So yes, you have most open source packages have CVEs associated with them. So now how do you prioritize those to go after the ones that will have the biggest impact to your company? So great feedback, great, I think use cases. There is no silver bullet. It is something that does take collaboration across, the DevSecOps model. It does require communication and education, I think mainly to developers. So of course, never blindly trust third-party sources. Sadly, I think this is still needs education to those developers, especially young or junior developers, without the education of some of the malicious possibilities that brings. Trusted sources, we can argue over what a trusted source is, but if you have the policy in-house and you have process and security professionals reviewing packages, that's a great solution to review what packages are actually in use and which ones are safe. Dependency management tools, we talked about SEA, and you'll see the term supply chain security or SES. You'll also see SSCS. Those are ones that are actually, again, there's no CV associated with malicious packages. So SCA scanners will not report on the exploits I showed today. SCS, ones that have a massive database. Checkmarx, we have a great research team that identifies these, not only the packages, but the actors behind them, and then the groups they're in, and then the network of libraries. We actually can see a global view of the impact and packages they're involved with. So that helps, at least from a reactionary standpoint, uncover some of those We talked about educating developers and then sharing with community. So conversations like this today, as you guys all talk with peers within your companies, talk with your other Austin peoples, it's important to share the awareness about these types of matters and make sure that there are controls in place to help. So that's all I had from a presentation standpoint. I think we have about 5 minutes left, so we'll open it up to see if there's any other kind of questions on supply chain security, on AI hallucinations, on dependency resolution or dependency checking. Anybody have any other last minute?
Yeah, sometimes you can end up importing third-party tools that have a significant open source library component.
Mhm.
And that, we talk about SBOM, but how many levels does your SBOM go down?
Yeah. What do you guys currently set it to for the level, the depth for SBOM, ballpark? 4?
Yeah.
I've seen 30, I've seen 50. I mean, to your point, then what point is too deep? So it's a great point.
Earlier you mentioned the AI hallucinations, that case. And you mentioned it with with respect to ChatGPT. Have you seen that and have data with other like LLMs, like some that are directly integrated with cloud providers like Gemini or anything like that?
Seen with Gemini, with Bard, and like Copilot, I know is integrated with, I think Gemini backs Copilot, correct?
Yeah.
So yes, we've seen it in those as well. We use ChatGPT in-house.
Okay.
So
Well, you had the data for it, like how many of them like were like incorrect, like it was like half for one that
yeah,
was
so like out of the 250
yeah,
were
exactly. Do you have
provided
data for like
fake.
those other ones or no?
I personally don't. I can
Okay.
see if we can share that. I think the ratio or I think it was comparable.
Okay. All right, cool.
Yeah.
Can you talk a little bit more of differences between SCA and SCS?
Sure. So, by the way, the market still has not been clear on what supply chain security means. Some people have SCA rolling up to supply chain security. So if we go way back to that first visual of just the process it takes to build, to create, build, and deploy software, it's sorry, team, I'm going to show this in the room only real quick. So, and there's a Salsa, it's called Salsa SLSA, that is a framework provided by Google that kind of highlights the different components for the software framework. The main difference being software composition analysis is looking at a database of CVs associated that have been disclosed and reported. And a lot of companies will have their own proprietary research, but it's typically tied to that, a CV. With malicious packages, with other type of exploits outside of that, which is very broad and growing, that is considered supply chain security. So what we saw with, why am I blanking on the massive one 3 years ago? Log4j, even SolarWinds. SolarWinds was kind of like when people were like, oh, now we need to check if our supply chain can be infected with malicious software. So that opened up the door for research and analysis on what supply chain means and what other attack points exist. Good news is it brought awareness, but also brought awareness to the bad people. And now they're finding even more areas that they can exploit. So software supply chain security is a broader term, in my opinion. And I think the market's still deciding of how that fits with SCA. In my personal view, SCA rolls up to software supply chain security. And then software supply chain is a broader kind of evolving term. Yeah.
Well, I'm sorry, I'm more curious about the tools, right? And so if you say software supply chain scanner, and how do you goes through the whole actual supply chain. Right. And if you're just saying the software and the dependencies, that's understandable, right? As you said, SCA is more based on the CVEs, but the supply SCS, you also want to look at the malicious software that doesn't have CVEs.
Correct, yeah.
Right. That's one aspect. The
yeah,
other
and-
aspect is
So I'll
how
just
does
speak
the tool
quickly at
go
the
through
kind
the
of
whole chain?
in the Checkmarx world, how we saw that. So we have an SCA solution. We also have a supply chain malicious package detection. So it's a massive database of all of the research that our team has put together. So even before going to Artifactory and other private package manager, instead of manually researching it, you get the benefit of our research and what we've already disclosed as malicious actors and malicious packages. So it's separate and it can be used, you know, you could scan at the same time. It's basically different analysis, different approach, and pulling back that data for our customers. So there's also secret detection, which may fall under supply chain, API keys and other secrets that could show up. So there's a lot of different components of the software supply chain, and different vendors will offer different risk detection for those.
So everybody's left. Let's thank Tyler for a great presentation. Great thoughts on all.
Awesome presentation. Thank you. Thank you, Tyler.
Yes, absolutely.
Thanks for
Thanks
doing
for
this.
those on the phone.
And hope to
That was
see
great. Thanks,
everybody- Yeah, hope to see everybody next week or next month. And actually at the happy hour too, hopefully. So see y'all in June.